So I do data science. I, I do data engineering. I work on developing software tools, mostly on the back end, but I also do some front end stuff from here to there. Um, and I also do a ton of CLI development. So I make a bunch of CLI tools. So if we have some sort of problem, my first my first thought is let's make a little CLI tool to make this like problem like reusable, and let's like throw it wherever we need to. And so like technical users can kind of easily hop in and kind of solve the task that they want in some sort of script. I really, really think it's important. What the command line gives you is some sort set of functions that are really reusable, and that's really important because if you have a problem, you're probably going to have to solve it more than once, and that's kind of, I think, the most powerful thing about software development is that it allows you to solve a problem that you had once a billion times over again in slightly different ways. And so, yeah, I'm also an Emacs user. I've joined the cult of Emacs, which is the lore for that. Um, so if you're a Vi user, I don't know, it's like sign of the devil. Okay. Uh, Jokes aside, let's get into more like the meat of this presentation. So, the core thing that I want to get at here is that vague requirements led to building something unexpectedly useful. There's this statement about mathematics, like there's this an uncanny ability for math to solve problems that people didn't think of. I think the same is the case for s- some software, like a generic some software meant to solve a generic problem also often solves specific problems that you didn't anticipate before, even with changing requirements. So it was kind of unexpected that the vagueness that I was challenged with, to start off with, led me to develop something that I think was is actually somewhat elegant. Um, Let me get into the story for this. So I was given this task. I was given, hey, we need to migrate from uh, these two ERP systems. And what ERP systems are enterprise resource planning systems. They're kind of product. They're product database user tools that allow you to describe your products and what sorts of informations those products have and things in your warehouse, that sort of stuff. Very like businessy stuff, and it does it so that people who aren't really that technical can also like interact with that system. So it's kind of a very like non-technical user focused tool. um, and so my task was, okay, we need to move from these two different systems, and they're completely different in their schema representations. They don't have similar ways to represent that data, and they have different schemas entirely. So that led me to think, well, I actually don't know what these two were. I had no idea what ERP was before I got into this. And even now, I still haven't used either of these ERP systems. All I've gotten is like templates. So, templates for what exactly this sort of thing is supposed to look like in this system, and source data. So, like from this other system that we have, what data do we need to put into that other system? So yeah, not getting instruction into like exactly how I'm going to do this, or a lot of details being missing. Like, okay, well, it's great that you want to move from these two systems, but what's the mapping between the two systems exactly? What does that look like, field to field? People didn't really have that knowledge because I'm dealing with a non-technical user base, so it was kind of frustrating. But it was also kind of liberating because it led me to figure out what I needed to do to solve the problem. Loosely, obviously, we need to move from A to B, but like moving from A to B, that's really, really vague. Like that means like what's A, what's B? Like you don't actually know, so you have to kind of figure out what that is and figure out how to move between these two systems and what kind of works. And I kind of want you guys to learn how to build tools in the face of that sort of uncertainty without being told, here, this is what you need to do. This is the problem you need to solve, and you need to solve it in this way. Like there's not really when you're not given that sort of direction. I want you to kind of like read this story and figure out, hey, this is how I might tackle like some sort of problem like this in the face of that uncertainty. So the initial problem, right? I kind of went into this before, but let's get some more detail on this. So my initial problem, obviously, I needed to move from the two ERP systems, and I also started off with a small code base. We're working with Excel files just to kind of fill you in here. So I need some Excel files from one system to like turn into something that fits with the other system in a very like strict form that of like non-Excel types. So I'm not sure what they use otherwise, but they have this kind of template. It's got format types and all that sort of stuff. And I wasn't sure if that would change or not, or what other examples would look like. All I knew was that I would get a bunch of these different templates in similar-ish kind of looking format. They weren't strict. They were created by humans, so they're not machine created. It's a person making all of these different templates, which means I can't rely on them all being identical. Instead, I would have to reformat the data that I had in a normalized way, right? So one of the things that you should remember is, okay, you get messy data. First thing you have to do is you have to make it all the same. You have to make it all the same, and you got to remove anything that's weird, right? That's another tip. I have this other tip here, which is talk to as many people as possible about the problem that you have in the face of uncertainty. I talk to um, I talk to my boss. I talk to people who consultants of the ERP system that we needed to use. I talk to internal people who are used to using the tool. Um, I talk to people who at like DuckTB. I talk to people at MotherDuck. MotherDuck is, by the way, MotherDuck is a cloud service that helps DuckDB. And DuckDB is a SQL database if you're not familiar. So this is what helped me help me figure out what problem I needed to solve and try to clear as many details and blockers as possible. Um, some of those questions were only possible after I try to work on the problem. So I actually try to work on the problem a bit, and you'll come up with new questions to ask. But really, wrap people in as many as possible. Just like keep wrapping people in. If you think you've wrapped enough people in to solve your problem when you're uncertain about it, you're not, because what you're trying to do is clear that uncertainty. All right, so let's talk about some of the like the evolution for how this project went. So I talked earlier about how actually I actually came from like a an initial user base in TypeScript, um, and then I moved eventually to Python. So uh, when I started initially in TypeScript, I ran into this problem, this really huge problem that kind of stopped me from being able to use TypeScript anymore. And that's because, well, the DuckDB API with TypeScript is kind of really early and not as developed as the Python one. That means like it's not going to support certain queries. It's not going to support prepared queries, user defined functions. And you'll find this a lot when you use some newer technology in your tech stack, is you will find a lot of areas of like, oh, this just won't work. I need to try some totally different solution. So you need to like be able to be flexible enough to pivot in those circumstances, not pivot totally what you're going to solve, but pivot the technologies that you're going to use in order to solve your problem and like choose them usefully. Because it was early on in the project, it did make sense to not drop DuckDB and to just go on to use Python. The reason why I decided to do that, to do a whole language shift like this, is because of the ergonomic benefits that come from Python from using Python with DuckDB. There's just a much better API, native support for data frames, like these sorts of decisions for why I made that choice. And that's really important. When you're early on in the project, you should try to make breaking changes that will help you solve the problem faster in the long term. It's totally okay to make big changes like that. Also, the tip, yeah, use as many external community to crowdsource ideas as you can. You like this is one of the great communities. I took and presented one of the problems that I had with getting my CLI tool to like work with while installing it, like pip install. Like why wasn't pip install working? I helped figure out that solution in this community. So I also asked all sorts of friends that I had that were pretty technical, "Hey, here's the solution." When they didn't have a solution, it didn't actually matter. It was kind of like, talking to the duck, if you're familiar with that term, which is like even describing your problem to other people that can't actually help you is helpful because it helps you like put your problem in a very clearly stated and articulated way so that you try to communicate in a bunch of different ways, which adds redundancy to the way that you've explained it and helps you understand your problem better. um, yeah. So this is another thing. So the architecture emerged from uncertainty. Each time I hit a wall, the solution to make things was to make things more generic. um, So how do I explain this? So I I think it is important to talk a little bit about the architecture. Um, and the architecture of this application is we have a bunch of modules. We have the core CLI tool and a bunch of modules that link with it. And I'll show you this later, like a really brief outline of how this looks like, and we'll go through a little bit of the code. But first, I just want to like tell you about it. Um, so we have like a core command line interface, and that can be linked with a configuration file that describes where different Python modules will be. So for a particular command, we'll have create a pipeline, for example, or run a pipeline, and that uh, pipeline, which is going to move data from one system to the other, will have a Python module that'll say, okay, this is what you need to do. These are the tasks that you need to do, and that core CLI will call is basically an API design for what will be in these modules. I did it so that, well, I don't know exactly what code will need to be run for each of these different tables or templates that I need. We will need to transform this data in a bunch of different ways that I can't anticipate. So how do I get around that? I dynamically, meaning at runtime, not ahead of time, uh, link to uh, modules that somebody has written, and that person was always me. But like the idea was just like, I will it's future me, not now me, or me in some other time, or maybe somebody else, right? They want to link a different module, they just tell, this is where the Python code that I want you to use that conforms to this API that we decided in these commands. So yeah, I think that was a really helpful thing every time we got very different source data and mappings, and the talks that I had with other people. Every time that changed, the requirements changed, it was really easy to just change the arbitrary code that I was linking to, and I didn't have to change the core design of my CLI at all. It's really cool.